Hello, our project is a self-automated smart doghouse. Our team name is EMP. Our team members are Enrique Hernandez, Fernando Murillo, Carlos Ramos, and Juan Palma. We chose to make this project to create an eco-friendly smart doghouse with a practical design, catered to pets rather than aesthetics, that would give them the adequate care when their owners are away. The doghouse will be able to run all of its components without increasing the owner's energy bill. More importantly, the doghouse will not leave a considerable carbon footprint for the increased comfortability of our pets. The target audience is anyone that lives with a dog. The focus is on those individuals who travel, have busy schedules, or simply want an improved lifestyle for their pet. There were two major problems that we noticed in other models. They were too expensive or inefficient. There are various custom builds for dog houses, but they did not seek to improve the well-being of our pets. Instead, they were simply built with more expensive materials that had luxurious style in mind over comfortability. There were other models that aimed to provide AC cooling to the doghouse, but they used generators to support the large power consumption that would not be practical with solar panels.
These are some of the earlier designs of our project and what we aim to design and build. Some of the main features seen on this 3D model are the automated water system located on the left side of the doghouse, where it measures accurate water level and fills the tank when low. Next to the water system, we have the dog feeder system that stores food and distributes portions throughout the day based on a timer. On top of the water, we have the temperature control unit that can read real-time temperatures inside the doghouse and display them, as well as adjust the temperature with a PID controller. The control unit located on the back of the doghouse is used to troubleshoot and make adjustments to the systems. Finally, on top of the doghouse, we have the humidifier, which cools the doghouse, and the solar and the battery, which provide power to the entire doghouse with clean energy. The timeline here represents our goals and plans for the semester to construct the project doghouse. We first allocated 1 week to change the timeline and adjust to meet real-time requirements with current circumstances surrounding society. We then gave ourselves 1 week to gather all necessary materials necessary for each component of the doghouse. Once all materials were gathered, we began construction with a total of 2 weeks per system to ensure we could build and test for errors. Most components needed more materials due to errors, which caused delays of ordering items to finish construction, which we did not take in account for. The construction of the doghouse was done within the allotted time as materials were easy to acquire. Once all components were finished, we assembled to the doghouse to display all systems as we intended. The water system of the doghouse was constructed with an Arduino Nano unit for a compact setup to ensure all items would fit within the box unit and deal with less wires. The unit uses a 2x16 LCD screen to display water tank levels and show how the system is operating when the water pump is on and off. The L317 module was used for the input of the voltage necessary for the system unit to distribute 5 volts to the Arduino and LCD screen while powering a 12-volt pump. Most of the circuit board components use resistors and capacitors to store and ensure that power does not overload when the unit causes any malfunctions. When the water pump is below 20% of the tank's level, the pump activates and begins to fill the water container until it reaches 100% capacity.
Hi, my name is Carlos. I was responsible for implementing the automated food dispenser feature of the doghouse. The feeder works by having a servo motor open and close a lid on the food container. The servo motor is connected to an Arduino Uno, which controls how often the food is dispensed and the amount of food dispensed. The dispenser dispenses food twice a day. The speed in which the lid opens and closes can also be changed to control the amount of food dispensed. The longer the lid stays open, the more food will be dispensed. This is useful since smaller dogs will need less food and bigger dogs will need more food.
Hello, I am Juan Palma, and I was in charge of the temperature control. The components that were used in the temperature control were a PID control, a solid state relay with a heatsink, a K-type thermocouple, and a humidifier. The way it was set up was that we had the power supply from the solar panels connected to the relay, the humidifier, and the PID control. The PID control receives data from the environment's temperature from the K-type thermocouple. The received temperature is compared to our desired temperature, and if we are not at the desired temperature, then the PID messages the relay to turn on the humidifier. This process is repeated by the PID control until the desired temperature is within range.
Hello guys, I am Fernando. I was in charge with setting up a proper solar panel and power supply for our automated doghouse. The off-grid solar system consists of 100-watt solar panel, one charge controller, one 12-volt battery, two breakers, a fuse distribution block, and a power inverter. Also, one ground distribution block for proper ground. I connected the design in this order. First, I connected the solar panel outputs to the solar panel inputs on the charge controller. Then I connected the positive terminal of the battery to the charge controller and the positive of the load from charge controller to the DC fused power distribution block. Our automated water feeder require 12-volt source, which are connected to the load output of the charge controller with the fused power distribution block. The PID controller is then connected to the inverter's AC outputs, and the inverter's DC inputs are connected to the fused power distribution block. Lastly, all of the negative terminals are connected to the battery's ground distribution block as seen on the diagram. In case of a shortage or overcurrent, there are circuit breakers at the positive wire of the solar panel and at the positive terminal of the battery. So with proper components, wiring, and safety precautions, the solar system installation is well built and flawless to power the automated doghouse.
Here we have a video presentation of our doghouse showing all components functioning as a single unit.
We learned that creating a renewable energy product is more complex than we initially thought. For example, we had to convert the solar panels DC power to AC power for the humidifier using a power inverter. We learned to manage our budget to keep costs low while keeping it efficient. This was difficult since solar panels are expensive but essential for making the house efficient. Because we have to work remotely, we had a few miscommunications and we were not able to help each other as much as we would have been able to if we were able to meet up on campus during the week. Meeting up and working together is essential for big projects. If we continue working on the project, we have some improvements we would like to make. We would like to make the design more durable and aesthetically pleasing by using 3D printed materials instead of cardboard and plastic bottles. We would like to improve the automated feeder code and add functionality. We could add a screen, a simple user interface. We could also make it more affordable and accessible by having different size models for different size dogs. That is all for our presentation. Thank you for your time.